Right. So folks, and on Zoom should be able to hear me now because I was muted, which just made everything I said earlier useless to them. But hey folks, thanks very much for coming along to .NET Knots. If I go right back to the start of these slides, then start at the start, which is a good place to start. We do this monthly, so some folks I recognise that have been before, some folks I don't, and this is your first time. Before we do anything, we've got a code of conduct in place. We like people to be nice to each other, and that's pretty much what's summed up in those words there. If anybody has any issues whatsoever, then if you're in person, then obviously come and approach me. Chris is a BGSS guy here, so I'm sure that if anybody's got any particular problems, you don't mind them coming up and seeing you. If you're online, then in the not too distant future, our co-host Connell will be arriving, and I'll have to make him a co-host when he does and sign in, and so there'll be a little bit of interruption, but you'll be able to send him a direct message in the chat if you're on Zoom. And with that, we'd like to thank our sponsors. Start with BGSS. We would be outside, which was cold, at least not raining at the moment. So thanks very much to BGSS for supplying the place for us to sit and chat. Cordius are a local recruitment agency. They're fantastic, and they're sponsoring the drinks, which I think most of you have found in the fridge in the middle there, and also the pizza, which I've ordered now. It should be arriving around 7:45. My talk is an hour, so I'll probably break for pizza because I'm hungry, and continue after we've had pizza. So for the folks on Zoom, you'll just have to eat your own pizza. Sorry. And JetBrains, we'll talk about them shortly, and PJG Creations is my company, and I do all the hosting and that sort of stuff, so I get to put it through the books. That's why that's on there. JetBrains, they're sponsoring us a single license for one of their products. If you've never used JetBrains before, then they make developer tools for developers, so things like IntelliJ, which I know Chris likes, and WebStorm, PHP Storm, ReSharper, and things like that. And if you tweet on the hashtag .NETKnots, then I promise at some point soon I will draw that. And I think I've got a backlog of a couple of these. So we'll end up giving quite a few of these away in the not too distant future. Christmas comes early for some folks. So I'm also a Microsoft MVP. I think I'm the only MVP here tonight at the moment. Yeah, as you do. But what that means is that it's a Microsoft reward for doing things like this, organizing events, speaking at events, contributing to open source, and that sort of thing, but obviously in the Microsoft space. So if that's something of interest to you, then do just come and ask, and I'll tell you what that's all about and what the benefits are, and how you can go about starting your journey to becoming an MVP. And this is me. Normally I'd be introducing another speaker and I get to go and relax, but none of that for me tonight. So we'll be talking about how to supercharge your data with Azure AI Search. Used to be called Azure Cognitive Search. For the eagle-eyed folks amongst you, you'll notice the name has changed, which is annoying if you've recorded stuff. Hi, come on in. How's things? Just take a seat, and we're only just starting, so it's all good. And Azure OpenAI, which is still going, amazingly, after the interesting developments of the last couple of weeks. Crikey. So with that in mind, that's the end of that, so I can stop that one. And we can flick over to this one. There. So I've got slides, and then I've got multiple desktops. So I'm going to be switching between the browser for some demos and Visual Studio for the code. And we'll be doing that in stages. If you've ever seen my talks before, you'll see I like to do that. I don't like to leave all the demos to the end and the slides at the start, and introduce these concepts as we go. So that should be all good. So a little bit about me first. So I'm a full stack development manager at Avanade in the UK. Actually, my background is IoT and software generally, but I've focused more in the Microsoft world recently, which is what we do at Avanade. So yeah, if you're interested in what Avanade do, then do talk to me about that as well. I'm also a Microsoft certified trainer and a dual MVP in Azure and IoT. A Pluralsight author and a meetup organizer, and I do software when I'm not doing all of that, it seems. And I'm also a STEM ambassador, driven mainly by my two little girls. So I like to go into schools and show them what it is we do. Mainly I take my IoT stuff in there, so robot arms and Oculus Quests and stuff like that, or Meta Quests, sorry. So yeah, so that's about me. So actually I thought it'd be interesting before we get going, should we ask OpenAI to write the talk? Let's see. So if we do write me a talk about supercharge your data with Azure Cognitive Search, and Azure OpenAI. Oh, it can't. What about if I drag some data in and drop that here? Data added. Okay. And then we copy my previous response question, paste that in. Sorry, you're on your own. Perhaps that's Clippy. Maybe not. Oh, geez. Oh, no. Now we've resurrected Clippy. This is bad. And Clippy wants to help. No, it's not worth the risk. So let's just close this window, shall we? Ah, no! Ah, geez. No, things are really bad now. The talk's ruined. Sorry, I couldn't help myself. But actually, it proves kind of a good point. I mean, firstly, I miss Clippy. I do like Clippy. And also, those Windows XP errors give me PTSD. But all joking aside, it can't do everything. We've all used OpenAI and ChatGPT. Right? Get signed in and I'll make you a co-host. And then folks aren't like this, oh, nothing's working. And that's not even the people on Zoom. But yeah, so it can't do everything. It's trained on data in the public internet for the most part. And that isn't necessarily always your data. So this talk's kind of about how we bridge that gap without having to train our whole model ourselves, which for the most of us is probably not something we really want to be doing. So let's go inception and we'll ask generative AI to tell us what generative AI is. And if we zoom in a little bit, this line here is really what sums it up. So it's deep learning algorithms that are trained on large data sets, and they use patterns and rules learned from that data to be able to generate new responses. Really, they're prediction engines at this moment in time. So that's the difference between generative AI and general AI. They're just predicting the next token and the next token. Not clever enough to do anything else at the moment. But again, it's trained on large data sets. So Stack Overflow and GitHub and Facebook and Twitter and stuff like that. Everybody else's data and not necessarily your own corpus of data. So we're going to concentrate mainly on large language models. So we've got AI and chatbots and natural language understanding as applications for that sort of model. And as a obvious bandwagon that folks are jumping on. So every big tech manufacturer, every big tech company is making them. So Google's Palm and Bard and Meta's Llama and Twitter's Grok just recently, and of course, OpenAI and ChatGPT. And within those, we've got categories of different types of models for different purposes. So in OpenAI's case, we've got GPT 3.5 and 4, Turbo now as well. ARDA for embeddings, which we'll come back to, and then things like DALL-E and Whisper for image generation and for audio. Then we've got Azure, and we've all been listening to the news. We all know that Microsoft have heavily invested in OpenAI. May have caused some friction with the board recently. But we get the exact same models in Azure for their OpenAI services we do in ChatGPT generally. And if you're lucky enough to get, oh, look, I'll let Connell in. All right, just give me a sec. It was you. Connell was probably like this. Hey. Participants. Right, now, see, I don't have to do much after this. I can let it all go to Connell. Where have you gone? There you are. Just one sec. I will make you a co-host. Yes. See how a sausage is made of organising meetups, and that should do for that. Good. Cool. So, yeah, exactly the same models. We get all of that, them same models I mentioned earlier, 3.5, 4, DaVinci, all of that lot. But we get to layer all of the services that Azure can offer you on top of that. So things like all of the security mechanisms, virtual networks, private links, which of course you don't get. Also, it's in theory sandbox to you if you use that service. You go and use ChatGPT, then that's likely to end up in their data set. Looking at you, Samsung. And we also get responsible AI. Microsoft are probably one of the leading companies to implement these guardrails for responsible AI to make sure that users don't go off track and get answers that you wouldn't necessarily want as part of your solution. And also that, well, they don't ask silly questions that they shouldn't be asking and stuff like that. So responsible AI, and Avanade, the company I work for, are also heavily embedded in making sure that that is front and center for all model training. And we get a nice multi-language SDK and, fast track your development rather than you having to deal with API calls directly. You can just download the SDK in practically any language that you'd want. Probably not Haskell though, sorry, but and definitely not Fortran. But likewise, C#, Java, all of that lot is supported in those SDKs. And not long before we get to our first demo. So that's good. And we'll get to see some code in a minute as well. So this is actually you watch, it'll probably have logged me out and I'll have to log back in again in a minute, but hey, that's fine. This is the landing page for the OpenAI service. It's the standard Azure landing page. So we get the details on the right and the standard portal menu on the left. We will need at some point keys and endpoints. Should I just show these and let everybody use my OpenAI? No. So we'll see this in the code later, but that's probably second most important menu on here. And the other one is model deployments. And you'll see, actually, that's kind of a dead end. You can't go much further in here without going to the Azure AI Studio. So here is the deployment. There's more on this page, but really this is the only thing I want to show you just here. Each of these different types of models, you name and choose the model and the model version. And you can see we've got GPT-4, DaVinci 3, an embedding model, and GPT 3.5. We're not going to be doing anything with DaVinci and 3.5. We're going to be looking mainly at GPT-4 and the embedding models, which is ARDA. And again, you'll see why we have to come back to that in a little bit. But what you can do is that you can open these models in the playground. And actually, this tool is really useful because not only does it give you the standard chat session in the middle, but we also get to set this model up with some panels. But we can interact with this here, assuming it's not signed me out. We could say, what was Microsoft's revenue in 2021? And all being well, we should get a response. There we go. So 168.1 billion for Microsoft. That's not very much. But yeah, so that kind of gives you the overview of those parts. I'm not going to dive too deep into that. I'll be coming back in a little bit, but let's show the app to begin with, shall we? So this app is what I'm going to be using to demo most of tonight's talk, along with the portal pages. And this is all open source on GitHub. There's a link in the slides at the end. And you could try going to that address, but you'll need to be added to my AD because I would be crazy to open this up to everybody to use. Oh, GPT-4, free. Thanks, Pete. And then I'll cry when all my credits are gone. But there's some links here. If you were to spin this up, then you'll be able to find me no matter what anyway. I had to change all of this because that's a cognitive search for a lot of these. And you'll see that in the code because I wasn't going to go changing that a few days before my talk. I'm not that crazy. But I did want to change at least the UI. And we're going to be going through each of these pages in sections along with the slides, just so that we don't overload people. But the chat page is one of the most important things, and I will need to refresh this page because it's lost its connection. And now, look, see, now it wants me to sign in. Oh, wonderful. Seems like you leave it for any more than a couple of minutes and it decides that it's going to sign you out. But we can do the same thing here. So, what is OpenAI, for instance? And all being well, if everything works correctly, we get a response back. So I've built all of this from samples to a degree, but this is all a Blazor .NET 8 app. So it's using all the latest stuff. But you'll see I've done things ever so slightly differently in the back end when we start looking in a second. But I've added some stuff in there like write me an HTML page. And all being well, there we are. So I've done the not code highlighting, but at least we've got a box there that you can copy the code out of. So I kind of use this as me getting used to OpenAI, SDK and that sort of stuff. So yeah, you should find that works quite nicely. So code. Let's have a look at what the code looks like for that. So again, this is a Blazor app, and I'm using the Blazor hosted model. So has anybody used Blazor? Whoa, a few people. That's good. That's good. So there's a few different ways of doing Blazor. You can do WebAssembly, or you can do Blazor server, or you can do this hosted version. So you get a WebAssembly front end and then an API backend essentially. And that's what I've done here for more than one reason. But the markup, I'm using Mud Blazor. Has anybody used Mud Blazor? Good. It's very good. Go check it out. It's actually pretty cool and free. So well worth checking out. I don't work for them. I'm not advertising. I'm not being sponsored. But I used it and it's cool. I like it. So I'm not going to dig deep into all of this code because why? So that's the markup for what you just seen there a minute ago. But what you'll see here at the top, and if you know me well, this is Signal R. And this is some of the boilerplate for Signal R. So there's loads of different ways I could have made a chat app. But one of the things that you can do with the SDK and OpenAI in general is that when you send it the query, you can get that streaming response back. So you saw the words appearing one by one. You could just wait for the whole block and then give that as an answer, but that's terrible UX. I could have done it with a streaming API if I wanted to, but one of the things you'll find with Blazor is that Signal R is almost baked into it. Certainly for Blazor Server, that is exactly how Blazor Server gets its DOM updates and sends its information back to the back end, is by using Signal R. And it's great. It's been around for ages. And again, if you've watched any of my other talks, then you'll see Signal R appearing in that. So, you know, we start off by hooking ourselves up to the hub, which it's just on the server. It's just sitting in the back end, and I'll show you that in a bit. This block of code here, we won't use. We might see it later, but you'll see it referred to later. But this is the different way of receiving a message back. So that will just give you your block, bump, which is why it's commented out, because I didn't want that. But at least it's there, so you can do it that way should you decide you want to do it that way. What we do here is we use this receive message token. So for each token that's received from the OpenAI service, we send that over Signal R, and the front end just picks that up and populates it. So that's what that piece of code is doing. And then when we send a query, we use Signal R to send it as well. And whether you do it via an API or Signal R, what this is letting us do is keep the front end lean and put all of that logic in the back end, which is what we can do by switching over to the OpenAI helper file. Don't worry about the fact that's really small on the right. You don't need to read that. It's the stuff in the middle that you need to read. There's a fair amount of look at this first bit for now. Oh, why is it saying preparing live stream? Did something happen? That's annoying. In the way. Go away. Well, I can't. Anyway, query OpenAI with prompts is where that query was ending up in the back end here. So we grab the Signal R client because we're going to be using that, but we'll need the keys. I've stored them in the secrets so that everybody doesn't see my keys. Be quite careful with that. And then we do some Signal R stuff just to say, you know, we're starting. You know, every time you do a query, you get like 3 little dots, sometimes animating. That's what that's for. That true is telling the system that that is a holding message. And then we create an OpenAI client, get my teeth back in. And then what we do here is prepare the query, essentially. So what you have is chat completion options, as it's called. And into that, we've got messages. Now, the messages are pretty much what you imagine them to be, only they're split up. I've only got 2 types on here, but there is a third. But system and user are kind of what they are. So system is saying, this is how I want you to behave model. And you can see, you can tell it to us to talk like a pirate if you really wanted to. I did that. It's quite fun. But I'm just going with a really simple, you're a helpful assistant. And then we feed in the user prompt here. I think in theory, we probably don't need to put it because I actually feed it in a little bit later. But I also pass in the previous messages to keep that conversational style. And for each of those messages, you need to tell it whether or not it's the assistant, and that's that third type of chat role there, or a user message. So was it a response or was it my question? And we just add all of those to those messages. So now it's got that block of conversation that it can base some context on. And then at this point, we go and complete that query. So this part here is saying, async, go get me all of that query response and start streaming it, which is what we're doing down here. So you can actually get more than one choice. You'll find we only get one choice. But here is where we're cycling through all of the tokens that make up that response. I'm not going to dive into what tokens are, but almost words, but not really, because it can be a word and a half or several. It's a mathematical thing that I'm not going to get too deep into, but just imagine they're a word at a time, because that's kind of how it's appearing for us. Actually, what I'm doing, rather than sending it directly, I'm using a queue, and then on a timer, I'm sending on a regular interval a block of that code, block of that response. If you don't do that, then it's lumpy and you'll get big blocks and little blocks, and it kind of doesn't look very nice. Whereas I like that almost teletype output. So that's why I'm sending it to a queue. This line here sends the whole message back. So remember that block of code that's commented out? That's what that's for, that I'm not using, but it's there nonetheless. We'll come back to these other types of query in a second. But at the bottom here, we've got that process queue that I was telling you about that's running on a timer. And we send a signal R message out to say, here's that latest bit of that token that I've pulled off of that queue. And that's really kind of the basics of how you interact with OpenAI there. So actually, I mean, there's some code down there that, we'll come back to. But there's not that much involved in there. A lot of it's just connecting to the service and then telling it how it works and then getting the response back. So the SDK kind of makes it nice and easy for us to do that. So going back to the slides. We live in a world of unstructured data, and that is everything: text, images, audio, video, and everything in between. And all of these models tend to be trained on that over the public internet, which is great. And it makes them, as I mentioned earlier, powerful prediction engines. This idea that you write your query and it kind of just figures out what the next word should be after that query, and then does that again and again and again and again and then again and again, and gives you an answer. So when folks are saying, are you a living, breathing, sentient thing, the response you're going to get is just going to be a predicted response. It doesn't know what it's actually said, not really. That's why you've got to feed this information back in and contextualize it so it can figure out what to do with it. But how do we do, this with our own data? Again, it's limited on what it's trained. You saw in that response earlier that it's capped at 2021, that particular model that we're using at the moment. So it doesn't even know anything in 2022, never mind this year. We use retrieval augmented generation, or RAG as it's politely reduced to. And what that does is allows us to bring our own data to these already trained LLMs. There's a few different ways we can do this. Obviously, you could train your own model if you wanted to, but that can be quite complicated. And GPT-4, for instance, is huge, well-trained, understood, everything's available to you. So why not leverage that with your own data? So we can store our data in a database of some sort and write a query, use the same query, to be able to get that data out of your database. And then we can combine those query results with that original prompt, that original query to OpenAI in our case, and it will then give you a response based on that data. So it then just opens up your data to the whole of the model, but only the parts you want. And we can actually demo this in the portal. So if you go back to the chat playground, it's still not signed me out, so that's good. And I mentioned earlier that we can set this model up. So on the right-hand side, we've got some information about the deployment. You see we're using the GPT-4 model here, and past messages are being included. And we can set some parameters here, the maximum number of tokens and the response and the temperature, and then some other stuff that we don't need to concentrate on. On the left then, we've got the assistant set up. And this allows us to be able to input that system message that we saw earlier. Now, this is its remit. This is how you want it to act, talk like a pirate or whatever. But we can actually add data to this. So we could say, use the following information to answer your queries. And what I've done is actually using ChatGPT. Over here, I've generated a fictitious set of accounts for a fictitious company called XYZ Retail. And these are the 2021 accounts for that company. And so there's a bunch of accounts all the way down here, and then an executive summary about what they intend to do. It's quite fun doing that, actually, including opening new stores and how cash flow is and stuff like that. And what I can do is I can Control A all of that and Control C and copy that to my clipboard, and then go back across here and then paste it in. Boom. So that's all of that data in there now. We don't need to worry about formatting. It's all good with the way it is. You'll see it's telling us to save our changes, so we must do that. And I'm going to clear the chat just to keep things nice and clean. And now at this point, I can actually ask it about XYZ retail. So let's just do tell me about XYZ retail, for instance. And using that data, XYZ Retail is a retail company that reported solid financial performance, which is nice. Generated a total revenue of 450,000, gross profit of 180,000, net income of 90. And we actually see some of those in these results at the top. So net income of 90 and gross profit 180. So you can see now that it's actually using our own data, which, I mean, that's actually quite a nice way to start working out your prompt engineering side of this. So how am I going to phrase my query to make it use my data correctly? But you can see actually on the deployment, we start using up our tokens there. So we've used 1,452 of our 8,000 tokens. This is an 8K model here. And it's not particularly useful to come in here and have to keep copy pasting stuff in. It's not the way we want to do it. So we need to figure out a better way. And we can. So we can use resource assisted generation, retrieval assisted generation. So what we do is we ingest the data into some sort of a database, and then we break that into small parts. This is called chunking, and then store that in the database, and then retrieve that using queries. So databases, pretty straightforward stuff. And the database we'll be using will be Azure AI Search, which used to be known as Azure Cognitive Search, which is probably what you saw on the meetup, at least half of you. I think it was, what, 2 weeks ago? Maybe it was Ignite when they changed that, and they had to go through and change all their docs. I do wonder, actually, if Microsoft had just got placeholders for names of services, because they change them every 5 minutes. They must do, because otherwise it'd be a right nightmare. Surely they're not just doing Control H. That would be bad. So this is a cloud-based search service, and it allows us to be able to query over our own data. And we can query it many different ways. We can do the Control F, query just with text to bring it back, and we can do a fuzzy matching with that, so that you don't have to use quite right spelling or ordering of words. And we can do proximity of words as well, and we can do something called vector search, which we will come back to. I'm just planting little seeds into your memories for this as we go. And of course, just like the OpenAI service, we get access to this multi-language SDK as well, in pretty much anything you like, so that we don't have to do API calls. Now, we need to talk about indexes and queries. So indexes, you can think of indexes as a table in a database. I'm kind of making links here that just make it easier. It's not quite like that, but the basic idea is that, where we've got schemas and fields that go into that. Within the fields, we can set these things to be filterable so that we can write queries against them, which is useful, and facetable. And funnily enough, until I started looking at this sort of stuff, I didn't know what facetable meant. What's that mean? But what that allows you to do is bring back all of the options in a particular field so that you can populate things like drop-down boxes and tick boxes, so that you can do your filtering that way. Quite a nice way of doing it. And we're able to write queries over the top of that data then. And for queries, we've got a few different options. The Control F, full text, which is practically just doing a find in that. Great for things like maybe autocomplete, or suggestions and things like that don't need to be too complicated, but also vector search, which again we'll come back to later. But vector search is a numerical mathematical comparison of two vectorized blocks of data, and again I'll explain that shortly. We can then do something called a hybrid search, which takes full text and vectors and combines them. So you do your vector search and then you apply a full text search over the top of it to try and re-rank your results there a little bit and give you a slightly better result set, the ordering specifically. And then we've got access to something called semantic search. Now, it's not really doing a search. What it's doing is understanding the semantic meaning of what it is that's in there and your query, and trying to figure out, does this make for a good match? And it actually uses AI models to be able to do that under the hood. But what it does is it runs this semantic re-ranking mechanism over the top of your results and just moves things around to make them, the one that's the most semantically correct be higher up in your result set. It is a paid for service after about 50 megs. You don't get to store much stuff in there on the free tier. And it's like $200 a month. It's not that cheap. But it does make a difference, even in small sets of data. Obviously, the more data you got, the more difference it makes. But you'll see that when I demo it later. So let's look at Azure AI Search. So that's here. So this is the landing page for Azure AI Search. And there's not actually that much to see here. Again, if you've not seen a portal page, then this is a portal page. Information on the right, menu on the left. We get keys, just the same as we did for OpenAI. There's two different sorts of keys here, by the way, you'll spot. There's admin keys and query keys. Now, if you want to create an app that's going to allow you to be able to create indexes, which I mentioned earlier, and I'll show you in a second, then you're going to need to use the admin key, because the query key, as the name suggests, allows you to query and nothing else. So just bear that in mind when you're doing it. And then we've got indexes. And I've already created an index in here and uploaded some documents, 3, not very many. Again, documents aren't quite documents. You'll see when I talk about it later, but at least you can see there's something in there. And we can go into this index and have a look at it. And that's what this is. So I'm going to ignore Search Explorer and come back to that. But this is the schema, or this is the table definition, if you will, of our index. And you can see we've got a bunch of fields all down the left-hand side are the names, and then the types. See, I've been super creative and just done everything as a string, because it really didn't matter for this. But you've got access to lots of different types. And then we can set whether or not they're retrievable and filterable and sortable and facetable. And you'll see when I demo it later, company and year are the facets that I can bring back to populate drop-down boxes. Searchable, and then analyzers and things like that. And you also see 2 vector fields at the bottom with their dimensions of 1536. So that's kind of what that looks like. There is some more tabs in here, but you don't need to worry too much about them. I'll kind of cover the contents of semantic and vector profiles in the code later. But Search Explorer lets you do some stuff. So I've got a cheat sheet here. This is what I was going to query. So if we just type that into the query for now, then what we get is a bunch of results back. So this is just that Control F search. It's not actually, but it is for what I've typed in there. And you can see we get returned a bunch of stuff here, including some information about the score. The higher, the better. The re-ranker score, which is actually that semantic re-ranker doing its job. And then we get some highlights. And again, this is coming from the semantic re-ranker. It actually gives you the facility to be able to, in yellow, highlight the text that it found. Quite useful, actually. And then the title of the document that it found it in and the content of that particular document. And then the location that it found it, because I've made that as metadata and filled that in as the metadata when I uploaded it. Company, year, file name, things like that. And then you can see a bunch of numbers. And that is the vectorized version of that data. So to give you an idea about a little bit more, we can go to the JSON view. And this is what it looks like, the query looks like in JSON, and it's kind of how you're going to be interacting with it at an API level. And you can see the search in there, and the query type is semantic, and it's using a config in there and that sort of stuff. It's got a query language in there, but actually relatively recently, you'll see that semantic search is language agnostic. So that has been defaulted in there, but we don't actually need it. But we can add a bit of JSON to that, for instance, just to filter what it gives us back, because that was a lot of data it gave us back. So if we just add this select statement in there, so I'm assuming most of you have done database work at some points, that's just a standard select. And if I do my search, now you see the amount of data we get back is vastly reduced, and we just get the content and the year back. So that kind of gives you a basic idea and a basic overview of how that's working. Normally, I'll just flick across to the app and show you how that's working in the app, but I need to talk to you about vectors first. So let's do that. Now, this could be hugely mathematical, and I'm not going to go into that amount of detail, but I do want to explain what these things are and how they work. They're a way to be able to convert our unstructured data into a numerical representation that AI models can actually understand and deal with. Under the hood, you'll find that's likely what they're doing anyway. So we take in that data and we convert it to vector embeddings. And we do that using an AI model. And the reason we do that is that when you use an AI model to convert this unstructured data to numbers, it's capturing the semantic meaning of what it is you're converting. And I'll explain that in a second. But what we do with those vectors is then store them in a vector database. There's loads of vector databases: Quadrant, Weaviate, Vice, and of course AI Search. Actually, AI Search is pretty new to vectors. I think it might still be in preview, or it's only just come out of preview. But it works. It's really good. So check that out. But it's allowing us to compare two sets of vectors when we store our documents in there, write a query over the top of it, and we can compare that. To give you an idea of what that means, if you imagine we've got the vectorized version of the word car, and that's the actual top half of the vectorized version of the word car. Now, if you wanted to do a search for, say, a lorry, if you can't really do a Control F to get that, or any form of like concept of, they're similar, because they are, both got wheels and they both transport things and consume fuel and stuff like that. But using mathematical analysis, it's a cosine analysis using this thing called a hierarchical navigable small world profile that it's doing, and it's terribly mathematical, and I'm not going to get into that level. But what it's doing is essentially, if you take each of those numbers and work out the distance between them, you can figure out how semantically close something is. Now, this isn't what it's doing, but if you were to imagine that, say, that top left number was, has wheels, how likely is it to have wheels? Then you could sort of do a subtraction and figure out how close that particular asset of that query and that result would be. That's definitely not exactly what it's doing, but conceptually speaking, you can imagine that you could do this yourself on paper. But there's 1,536 of those numbers, and it's more complicated than you can imagine. But a better way to explain it is, and if you've looked at this in any way, shape, or form, you'll have heard about the king-queen vector example. So if you take a king and a man and you subtract them two mathematically, and then you add a woman, the vector you get out on the other side is there. It's a queen. So just to do that again, we subtract the man away from king, and we're left with the crown, if you've watched the latest season. And then you add in a woman and combine the two, and you get a queen. And that is quite a nice way of cognitively understanding how you're capturing the concepts in there. You can just subtract a bunch of numbers from one thing, and it takes that part out, and you can add it in, but the concepts still remain. But geez, there's loads of videos on YouTube. There's a computer file video that you'll see some of that example in, and I highly recommend you go and watch that, because they explain it really well, actually. But, and I've got no idea if this is actually going out to YouTube or not. Is it on YouTube? Oh, I see. My beautiful helper over there has helped me out with that. So what you can do is you can plot vectors in a 3D space, and that kind of helps to be able to understand how these things work, other than just calling it a clever thesaurus. And so this is a video. It's not me dragging it around, but I've got this running. So this is using TensorBoard on Google Colab. It's dead good. All of these are the metadata from a bunch of IMDb reviews. So you'll see that it's not all single words. Some of them have got underscores, but you'll see things in there like moving and voice and stuff like that. If I scroll it across to the side, we can filter this by a word. So if we put delight in here and filter by that, you'll see now we've got a result of all of the words which sort of coincide with delight. It's like a word cloud, but it's not, it's far more intelligent than that. So mathematically speaking, these words are close to the word delight. So you'll see things like definitely and perfect and beautiful and heart and stuff like that. So these are all positive words. So if I scroll this to the side, correct side, and then we put terrible in here rather than delight, and filter on that, you'll see instantly all of the words have moved to the opposite side. So in vector space, these words are not like the other ones. So you'll see in here horrible, stupid, boring, hopefully not reviews of my talk. And you can sort of see then that it just gives you this concept of this numerical representation allows us to be able to figure out what's close to something and what's not close to something. So when we've split all of our documents up and we put them in our vector database, and then we query over it, it kind of knows the meaning of what you've captured rather than just a Control F search. So there's 3 different examples there. Hopefully at least one of them sat with you and you've got some idea about what that means. So some more AI search. Actually, let's go that way. I should say demo, so it doesn't confuse me. Let's have a look at the app. So I mentioned that there's several tabs here, and we have an AI search tab. And I also mentioned that there was an index already uploaded, and I loaded a document to that already. So I can do queries in here like, what was XYZ Retail's net income in 2021? And we get some results back from that. And you'll see I've only actually uploaded the 2021 results so far because I'll demo uploading in a minute. And we can see we get 3 sets of results. Now, there's very limited data. So here we go, oh, of course, it's going to return everything. But this is returning the 2021 results here based on that vectorized search. I've got other types of search we can do here, but we really don't have enough data right now to make that worthwhile showing. So I'll come back to that in a little bit. But I just wanted to show you how that code works on that side. So we're kind of building up the knowledge of how this is all working. So I'm just going to close these 2 so we don't crowd ourselves out. And then we've got here, we can go to the AI search page. A bunch of markup, just like we saw previously, which I'm not going to dive into too much. Again, Signal R, and we're receiving back on this one just the search results. And then down here, we're just sending a query out with our query to the cognitive search, as it's called in here, the OpenAI helper. So again, we're just keeping the front end lean, but I just wanted to show you that side of it. Now, there's loads of code in here as well, but I'm going to piecemeal my way through it. The only piece we really need to worry about here, not OpenAI helper, cognitive search helper. The only part we need to worry about here is this part down here. So skip a load of it and we'll go down to single vector search. So that's what we've just done there a second ago. Now, the first thing we need to do when you're doing a query over vectors is that you need to convert your query to a vector. So I explained there, we compare these 2 vectors. So our documents against the query. So the examples I showed you were single words, but you can obviously encode the meaning of a query as well. So you do that first, vectorize your query. And then we give it some options, and we need to tell it how to go about doing this query. So nearest neighbor is saying how many I want it to actually return. And then we're telling it to query against that content vector. You remember I pointed to that with that 1536. And I'm telling it to bring me back those fields. We can also filter on this. So there's metadata when you upload these documents, you saw the fields, and you can filter on that as well if you want to. And then we tell it to do a search, and it gives you a bunch of search documents back, which are just a dictionary. And so I convert all of them. I'm sure there's a better way, but I convert all of those into a class. So I've got something a little bit more static like that. And then you can, if you like, filter these results on a score. I've left the code in there, but I'm not using it because I just wanted to return everything for this particular example. But if you clone this code, you'll see that. And then at that point, I just return my cognitive search results and then display them. So that code is pretty simple. Now, I mentioned hybrid search, where we do the Control F on top of that, and that's just here. Now, this code is virtually identical to the code above. Not very dry, don't point that out. but for this demo, it's fine. And the only difference here is that I'm passing the query in as a parameter to that search. You'll see above it's just null. Boop. Yeah, so that's the only difference between these two. And that does help to re-rank those results into a slightly better score for the ones that are a little bit more appropriate. Then a little bit further down, we've got the semantic hybrid search. So that's doing all of these things together, but it's doing that semantic re-ranking over the top. So it's almost identical, only we're telling it that it needs to use a semantic search and a config, and then you can pull out the highlights if you like. And that's about the only difference there. Again, you'll need the semantic search service spun up, and then you'll need to refer to it to do this. And again, if you want any more than about 50 meg, then you're going to need to start paying for the paid service of that. And again, it's like $200 a month, so not cheap. I get it free, so I don't need to worry about that. And then we do the same thing down here. We just return those results. There's some facets here as well, which you'll see on the next demo. But you see, there's not much actually to get cognitive search working. So you've seen OpenAI and how to get that working. Not much code, fair amount of boilerplate, and then cognitive search, not much code. It's the reason why I love SDKs, of course. So let's go back and continue on a bit. So let's look at retrieval augmented generation, RAG, from now on in detail. We start off with a front end of some sort, obviously. And we connect that out to an API at the back end. And then that API has got access to Azure AI Search and Azure OpenAI. And then a user comes along and uploads a PDF. Oh, look at that animation. A user comes along and uploads a PDF to the API. And then we split that API up, that PDF up into chunks and generate vectored embeddings for each of those chunks. And then we store them in our vector database. Don't worry, I'm going to repeat this again in a bit. And then at some point later, a user comes along and makes a query. We send that query to the API in the back end. Then that goes out to OpenAI and vectorizes that. So now we're using this ARDA model, this OpenAI ARDA model, to create all of these different vectored space embeddings that we can use for comparison. We ask OpenAI to make a comparison between our query vector and everything that's in the database, and it gives us a set of results back. We then take the original query, combine it with our search results, and then we send all of that lot with a little bit of extra prompt telling it, just like you saw, use this data, to OpenAI, and then it gives us a result based on all of that data. The response that we get back is plain text, not vectors, from the OpenAI, from the AI search service. So we combine that lot up together. So it's important when you ask it, you saw that K was set to 6. You've only got a limited number of tokens to play with. If you try and send it too many, it's going to fail. So you're going to have to try and be careful of how many sources and how well it's ranked. Hence, semantic search can actually make this a bit easier for you, because you're almost guaranteeing that those top 3, maybe, or top 6 are going to be what you want. And you also need to be careful on how big you chunk your bits up. Anyway, we take that response, send that back along with those search results back to the front end for the user to be able to see the response and the sources. So let's have a look and see how that works. And at some point, Connell, I'll be getting a phone call from the driver downstairs. So I don't know whether or not you wanted to go down and collect it or somebody else, or if you wanted to nip down. But pizza will be arriving soon. And if it arrives before I finish my talk, then I'll stop, because I want to eat pizza too. So let's go to the app. So go to this OpenAI and AI search page. And this is kind of the part that you came to see, really. So at the top here, we can upload files. And then we've got some filters. And this is that facetable field being brought back, you'll see. So only got one company uploaded and 1 year. So not particularly interesting at the moment, but you can see that. And then some options, which is really just do you or do you not include your previous messages. It's entirely possible to write the solution and not include your previous messages if you don't want to have like a discussion-based, chat-based interface. It could just be a question and answer, which might work fine. So that's why I left that in there. But we can do the same thing here. So we can say, what was XYZ's retail's net income in 2021? And on the right-hand side, see, it's super quick this is. I know it's not lots of data, but you can see how quick that is. And I'm even on my VPN to home to a Raspberry Pi, so you can see that this is pretty fast. On the right-hand side, we got all of the sources, and they're the same sources you saw in the AI search page. And we fed that with a prompt, which you'll see shortly, to OpenAI and said, here's my query, here's the sources, give me an answer. And it's come back and said, its net income was $90,000. And just to remind you, over here on the PDF, net income was $90,000. So it's found that. So the search service has taken our query, got it all vectorized, given us a set of results back, which makes sense in text. We've taken that original query, added in those search results, sent that to OpenAI and went, leave it with you, tell us what that answer is. And it's come back and give us something sensible. So again, this is all sandboxed in there. So you're not giving OpenAI all your data. We hope, Microsoft are telling us that you're not, so that's the plan. Anyway, we're now being able to use our own corpus of data and not rely on the stuff that's on the public internet. So that kind of gives you the basic idea of how that works. But I say it only knows about stuff that we've uploaded. So in theory, on the left-hand side, when I do a 2022 query, I'm sorry, I don't have that. But what you will see on the right-hand side is we still get answers. And again, conceptually, give me the answer for 2022 is pretty similar to the 2021 query. So you can see here where you do need to be a little bit careful about believability, just like in any OpenAI query, you need to check your data. But we can actually upload our files here. So if I go here and upload documents, I can upload the 2022 results. And then it extracts that. So you'll see this in the code, chunks it up into bits, creates the embeddings, stores it in the database, and now that's uploaded. And if I refresh my page and go to filters, now we've got XYZ, of course, but we've also got 2022 in our results. So we could filter on this, but you already know what that'll do if I do it. But if I ask that same question again now, XYZ's retail income in 2022 was 100,000. So yeah, and it was, trust me. So yeah, that kind of gives you that basic idea. But what you will see on the right-hand side, if I scroll down, is there's still a 2021 result in there. And in fact, if I do the 2021 version, then we're also getting 2022 results. So that's great, but that's not too bad. But actually, if I do this in the AI search page and just do a vector search, we can sort of see what this means. So just the vector search. So this is just compare like for like vectors. You see that second result now? So in order of score, the second result was a 2021 one. That's not great. You won't necessarily know that because you've just sent it to OpenAI. So we can move them a little bit. So actually there's more than one. So there's two 2021 results, yeah? That's what we've got today, just two. If we go to that simple hybrid search, remember this is combining Control F with vector search, and ask that same question again. We still get a 2021 result in that second place, but that second one has disappeared down towards the bottom. So that's made a difference. Still not great, still not what we want. But if we do a semantic hybrid search, and that's actually what it's doing over in that OpenAI and AI search tab page by default is just the semantic search. If I run that, we now see 2022, 2022, 2022, 2022, and the last result's 2021. So you see now it's recognized the semantic difference between those and moved it down. And that's super important if you want this to just work and you don't want to have a lot of user intervention. But it's also the reason why we show the results. We can expand these, by the way, and dive into it. If I'd have had more time, I would have added the highlighting in there. It does look pretty cool, but just, imagine that it's done that, but in yellow instead. So that it can extract that information and then you can add it. So that's that pretty much that demo, but we want to see the code. So let's have a quick look at the code. So I'll leave Cognitive Search Helper and OpenAI Helper, but I don't need that one anymore. And we can then open up the OpenAI search one. So there's more code in this, more markup, and I'm not going to dive into that markup, but saw what it looked like. We've got a bunch of controls at the top and then the responses on the left and sources on the right of the query. So that's what a lot of that markup is doing. I've not had any phone calls. So it's anywhere between now and 8 o'clock. So it's going all right. Little bit further down, we've got the code here. So again, Signal R, just like we had before. We receive a message token. So this is exactly the same as we saw on the AI search page. And then we've got the cognitive search results, and that's the same as we saw on the AI search page. And that's not what I said before, but you know what I mean. And then we also get some facets back. So that's the filters, the drop-down list filters that we saw there. And we fill them up. And then we also get the upload file status. This is one of the reasons why I quite like using Signal R, because we can be processing all of that lot in the background. The APIs, we're not using one, so it doesn't need to be sat there connected. We just have that simple Signal R connection going, and we can deliver all these status updates. Now, if you're uploading quite a lot of documents, that's quite nice because you can just get that UX to be reactive and working nicely. So I quite like that. And then a little bit further down, we get the filters, just like I said, so filling those facets. Here's where we're sending the cognitive search query. It's pretty much exactly the same as the OpenAI query and the cognitive search query combined together. So we send the cognitive search query. And then uploading the files, I am using a REST API to do that, because really you shouldn't be doing that with Signal R, let's be honest. So what that piece of code is going to do is hit the API on the other end, deliver the file, and then we can see what it does at that point. So we've got the file upload controller here. Again, you see all the Signal R processing messages that I'm sending back. But we create this PDF helper, this class that I've created here. I'm using something called PDF Pig. Has anybody used that NuGet package? Quite good, actually. That allows me to then extract paragraphs out of that PDF. So it just reads it in, and then I can use a bit of maths to say, anything more than about 200 characters and anything less than about 800, I want you to grab me a block of that data, chunk that data. And I get all of those extraction results back. And then in the cognitive search helper, I then create or update an index with that extraction result. So I can actually see that on the cognitive search helper. That's right near the top. I scrolled past this earlier. You were doing that. So create or update an index actually composes the index first. So I've split that up into 2 bits. For an index, we've got this vector search. So we need to tell it what sort of vector search we're going to be using. We give it a name and a config name and tell it which algorithm to use. And you remember I mentioned it uses something called hierarchical navigable small worlds. That's what that HNSW does. Now, what that's doing is, if you imagine Google Maps and you're trying to find a lake, you'd zoom right out and you'd try and find something that kind of looks like a lake, and you'd zoom in and, oh, it might be the lake. There's one there. I'll choose that one, zoom in a little bit further. Oh, that's that. It might be that lake. I'll zoom in a little bit further. That's conceptually what HNSW is doing. It's a layered-based system, and it's doing something called greedy searching. And so it starts with this wider view of the world, and then kind of zooms in and in and in and in and in, like trying to find your mates in a really busy pub or something. It's like, it might be over there, and you just work your way through to it. That's what it's doing under the hood. So you need to tell it which one of these algorithms. There's a bunch of them that you can use, but that's kind of the standard one that folks will be using, HNSW. And, just remembering the blooming name's one thing. And then we've got the semantic settings here as well. So we're adding in that semantic re-ranker and the config for that. You give it some keyword fields here so it can get some extra context, and tell it that it can use the location of the company, the year, and the file name to try and glean that information. So you can see year, as I was doing 2022 and getting 2021 results. That's where it's been able to do some extra searching over the top of that. But it's, I don't like calling it search because I feel like it's not really search, but either way, that's what it is. Then we define all of our fields, and you remember that grid of stuff I showed you in the portal? Well, this is where all of that comes from. And we set things, whether filterable, sortable, facetable. And then at the bottom, we've got those vector fields. And here that's that 1536, because the ARDA model produces 1536 as the number of vectors. So we need to tell it that so it knows what to do. And the vector profile that we defined above and how it goes about doing it. And then, yeah, at that point, you can see, I've gone too far. We then just go ahead and upload our documents to it. You know, those extractions, we need to upload them out of that. And we actually return a bunch of extracted paragraphs as well, but that's not massively important. A little bit further down. Pizza. What's that? Hello? Oh, excellent. Are you downstairs? Excellent. Somebody will be there. Oh, yeah, brilliant. Somebody will be there in just a second. Thank you. Okay. All right. He'll come and find you. You'll see. He'll come and stand outside of the building and start waving at Domino's people. All right. See you shortly. Bye. Sorry, folks online. You don't get the pizza. And I'm close to the end, so this is good timing as well, actually. So it's all good. So we've got those searches that we did there, semantic hybrid searches, and getting facets, as we saw, creating and updating indexes, composing indexes, processing extractions as well. Don't need to dive too much into that because I've explained kind of how that's working. One thing that I will just show you is I've mentioned SignalR quite a lot, and everything goes through this thing called a chat hub in the middle of this. And so you can see there's the send query. So we use that just a string to say this is what we're calling, and then you have a hard-coded handler here, send query, send a cognitive search query, query cognitive search on its own. But you can see that send cog search query is doing just the cognitive search results, doing a semantic hybrid search and getting that result set back. And then we create an OpenAI helper and tell it to use that result set and our query together and do that. And then query cognitive search on its own, which is for that AI search page, and getting the facets. And that's the code. I could show you the PDF helper, but it's not really helping you that much to see that. So let's go back to the slides. And I just wanted to recap on this because I've covered a lot. But again, for RAG, you have a front end of some sort, and you hook that up to an API which talks to Azure AI Search and OpenAI. Somebody uploads a PDF. We then break that PDF into bits, chunking, converting those into these vectors, these magical vectors. And then once we've got those vectors back for those chunks of text, we store those in our vector database. And then at some point, somebody comes along with a query, and then they send that through the front end to the API. You need to convert that query to a vector so that we can do this similarity search. Send that to the OpenAI service, and it gives you a bunch of those results back using whatever method that you've asked it to do it with. Take that original query and combine the two things together into a set of prompts and sources, just like I showed you in the portal. And the API sends that to OpenAI, asks it to do an inference over all of that lot. That all goes back to the user with those sources, and hey presto, now we've brought our own data to OpenAI's chat GPT, essentially. And yeah, that's it. So I mentioned code is all open source, so you can find that there. What I'm going to hopefully do with the help of this very clever guy here is improve on, or actually fix my ARM templates so that you can just spin all these services up together. I struggled with trying to get OpenAI and the models to go in the same set of ARM templates, so I didn't spend long on it. But I'd like to be able to just have an ARM template that spins all of this up, and you can just do it yourself. So you can look out for that. If you want to know a bit about the Azure OpenAI service and the Azure AI Search service, then do. And then there's Microsoft's retrieval augmented generation overview as well. And then within those links, you'll find links to their open source examples. You don't need to worry too much about taking all that down because that QR code will take you to these slides. So go ahead, by all means, and scan that QR code. But I will be tweeting this out at another point as well. Or you can go to that bit.ly if you can't get your camera to work. And with that, the timing is perfect, but we will do some questions. I'm not a data scientist, so I'll preface that to your query. Embed that in your sources. Any questions? Everybody's heads exploded. Go ahead.
How do you know which size the chunks should
Hmm.
when you split it?
Yeah, so that could be,
one chunk and includes two completely different information.
yeah. And in fact, chunking is a science on its own because you lose context when you start chunking, and the smaller your chunk, the more context you lose. And again, that vectorizing is capturing the semantic meaning of that chunk of data. And if it's really small, it's not got much semantic meaning to work with. So you kind of want a bigger chunk. But if you make it too big, then you can't have many of them to be able to feed OpenAI with because you'll overflow your token limit. So it really depends on the context of your data. There are ways to fix this though, and I didn't go into a great deal of detail, but it's worth pointing out that, again, you do lose context by chunking, and the metadata helps to add some of that context back in. But what you can do is that you can, as you create the vectorized embeddings for each of those chunks, you can send them to OpenAI and ask it to summarize it. And then you can add that into either the metadata or directly into the text if you wanted to, and then store that so that you don't lose all of that context of what that chunk was actually meaning. And another thing you could do is something called a sliding window approach, where instead of just going chunk, 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 you chunk that bit and then overlap and overlap and overlap, and then you manage to get some more context out of it. But to answer your original question, really going to depend on the data. If you imagine those accounts there, I can capture quite a lot of information in a chunk, and it's not very big. But if it's, I don't know, if you imagine, you can actually do images as well. But if it's really condensed data, then it's going to be difficult to try and figure out what makes sense for the context of that. So again, applying those other techniques, you can reduce the size of the chunks, meaning you could possibly either have more of them or leave you more space for a conversational style query. But I don't have a direct answer to that because it depends on your sources. Yeah. Is anybody doing anything like this, by the way? I know the answer is yes at BGSS. But really? Okay. Uh-huh. Yeah, yeah. Okay, cool. Yeah, yeah. But well, yeah. I mean, I'm hoping that I've kind of made it look not too difficult. There's steps, lots of steps, but actually those steps conceptually aren't that difficult. The SDKs help, the docs help, talks like this, hopefully. I don't see a huge amount of talks on this actually, so yeah. But there's a million different ways of doing this as well, of course, but I like this because it's already just using all the services we've got available to us. A lot of people are already doing the OpenAI part or indeed the search part, and they just need to plug the two things together and make them understand each other. But yeah, was there any questions in the chat, Colin?
No questions. I'm kind of repeating what's said.
Okay.
When people do ask, can you repeat them for the?
Oh yes, good point. Yeah, normally I'm telling people to do that,
yeah,
and here's me doing it and not telling people. So, yes, good. Did you tell them what the question was in the chat? Yeah, thanks, Colin. Appreciate it. Apologies, folks.
Well, I didn't remember. Somebody in the chat that I reminded me.
Well, do your job. I do 2 different jobs at the same time. Give me a break.
You have to repeat what I just said.
Oh, more Inception. Actually, I wanted to show you one more thing before we stop. Sorry, I know there's pizza. But I know I kind of told you that I like Clippy, yeah? Watch this. Woohoo! Now it's in Clippy mode. Let me zoom in. I can move him, look. And now I can say, what's Microsoft's mission? And Clippy answers, which I love. There was an open source GitHub repo that somebody had deconstructed the originals. Now all of them are in here. I don't know if you ever used Clippy, but there's wizards and cars and all sorts, and you can use them. And all the animations are in there. Everything's in there. And so as soon as I saw that, I'm definitely going to build that in there. And actually, I quite like it. And I think Copilot type idea, that isn't such a bad way of doing it, because often these Copilots are sidebars, yeah, and they take up a load of screen real estate and probably doesn't need to. That concept, not too bad, I don't think. Certainly, maybe, you know, if you click on him and get the answer back, which it doesn't do at the minute. You're a bit late. They're a BGSS person. We can admit them. Right. That's still a good bit. Say again? Oh, okay. Yep. So yeah, but I know it's silly, but I missed Clippy, and really I think for a lot of people this is kind of like the grandfather of OpenAI's stuff. But I thought it was quite cool. You know, you stick that down in the corner of the screen and use that as your co-pilot. I think I'd use that. Oh, Microsoft, off you go. Leave it with you. Oh, I've done it anyway. Just clone my code. So yeah, so that's it. So again, there's the slides. Do feel free to take a copy of that. Do feel free to clone the repo, make pull requests, tell me how my code is terrible. And other than that, thank you very much for coming. And thanks, folks. I'm going to leave you folks. I'm going to stop this whole thing, but we're all going to go and eat pizza. So, but thanks very much for coming. We haven't got a December meetup. Because that would be on New Year's Eve or thereabouts. And although I'd probably quite enjoy that, I think a lot of families wouldn't. So we won't do that. So we'll be back in the new year. I'm not quite sure who we've got in the new year. I think in February, though, we've got Matteo Amelli, who's a fellow Avanade employee with us, MVP, really good. So I think he's going to be coming and speaking about OpenAI or DevOps. So that'll be worth looking at in February. And then I'll let you know what happens in January. Again, I run more than one user group, Knots IoT, which when we're in person, BGSS very kindly offer to host us here for that. But the first one I think is going to be in February for that one as well, possibly because it starts getting a bit too close to Christmas. And that'll be Sander van der Velde talking about possibly Fabric, if you've used Fabric, and how we can ingest IoT data, which you can replace IoT with just data into Fabric. It's quite a cool talk, that is. So thank you very much for coming, everybody. I'm going to leave it interesting. Yeah. And apologies, you've had chin cam the whole time if you're on Zoom, but you know, that's what it is.
Thank you very much. Goodbye.
Thanks, Stefan. Bye.